Now, one of the hardest things to do in this topic is to analyse the graph of a rate and figure out some things about what would be the function that you'd get if you integrated that rate. Now, the reason it's hard to do is because we don't actually have an equation for this rate, and so we can't actually use our algebra to integrate it. We have to take information off the graph, think about what it means, and answer questions carefully. So this graph shows the rate of growth in a frog population. Before we get to any of the questions, let's just make sense of it and sort of tell a story. Now, it's really easy to get the story wrong. You could look at this graph and think, oh look, the rate of growth is going down, so therefore we must be getting fewer and fewer frogs. No, what you need to look at is find the origin and think about what is actually a negative value of the rate of growth, that will be down here, and what's a positive value. Because this whole section of the curve here and here tells us that the rate of growth is actually a positive number. That means that the frog population is growing. The fact that the rate of growth is going down means it's maybe not growing quite so fast after 3 or 4 days as it was after 1 or 2 days. So the rate of growth can be decreasing while we've still got a population that is getting bigger. So be very careful with these questions. What's happening in here? Well, the rate of growth is now negative. It's a little bit negative, and then it's very negative, and then it's not so negative, but still going down, but not at such a rate, until we're back to 0 again, and then we've got a positive rate of growth. So let's answer the questions carefully. When was the population increasing? Well, for a population to grow, the change in the population with respect to time has to be positive. And it's actually positive for this whole section here and this section here. So I'd say the population is increasing when t is between 0 and 4 and when t is greater than 12, because that's when we've got a positive section on the graph. When was the population decreasing? Well, for a population to decrease, the change in population with respect to time has to be negative. It's nothing to do with the shape of the gradient of this graph, it's the fact that it's below the t-axis, or the horizontal axis. So that's happening here between day 4 and day 12. When is the population neither increasing nor decreasing? Well, that would mean that the rate of change was 0. So that happens right here and here, when t equals 4 and t equals 12. When was the population decreasing most rapidly? Well, we know it's decreasing for this whole time, and the numbers that would be on this vertical axis tell us what the rate of decrease really is. So it's at its biggest time of decrease right here at this stationary point, and that seems to line up with time of 8 days. All right, when was the population at a maximum? Now, think. We need to tell a little bit of a story here to work this out. We don't know how many frogs there were in the first place, but we know that the frog population was growing. Even if the rate of growth was getting a little slower, we were still getting more frogs for this whole time. Once we hit day 4, we started to get less frogs. And we kept on getting less frogs all the way up to day 12. After that, the frog population started growing again. So if you're thinking about when there were the most frogs, it doesn't make sense for there to be a lot of frogs anywhere down here because we're losing frogs at this time. Also, we're not quite sure how many frogs we've lost through here because we don't have any scale on our vertical axis. So I think it's safe to assume that the time that we would have had the most frogs is here at day 4, because at that point, the frog population had been growing and we hadn't lost any frogs yet. After that, we lost some and then we gained some, but we're not entirely sure whether the number we lost and the number we gained might be equal. And there's not enough information on the graph to tell. So I would be conservative and say that t equals 4 is when we had the most frogs. After the 4-day mark, when was the population at a minimum? All right, so after that, we were losing frogs from day 4 all the way up to day 12. Now, just because we lost the most frogs per day, around about day 8, that doesn't mean we had the minimum frogs then, because the population was still going down right up to day 12. So I'd say that day 12 is when we had the least frogs. After that, the frog population started growing again, so we would have had more. All right, draw a possible graph for the population over time. Now it says a possible graph because we don't have any information on our vertical axis here to give us any real figures. But we've got some basic ideas of when the population was going up or going down. We also know that there must have been some frogs at all times because the frog population couldn't have grown if they'd fully died out here because there wouldn't have been any frogs left to reproduce. So a little bit of logic like that, common sense, goes a long way. So let's make something of a graph. It doesn't need to go down into negative because we know that we have frogs at all time. We've got population and we've got time. We thought that we had the most frogs after 4 days, so let's put the same 16, 8, 4, 12, we'll put those same markers on. We think we had the most frogs around about day 4. The number of frogs we had at the end and compared to the beginning, well, we're not quite sure, but we were definitely getting more frogs for those first 4 days, so I'd say this went up to a high point. Then we were losing frogs, and the day we were losing frogs the most rapidly was day 8. Now, if we have a turning point here, we need a point of inflection here, because if I have my graph going really steeply down here, remember the gradient will be the most steep at this point, and that is what shows the biggest change in the population over time on this graph. Then we had our minimum number of frogs at day 12, so I need to be a point of inflection around about here, going down to a minimum point at 12, and then our frog population went up again. We're not entirely sure exactly where it ended, but this is a possible graph. And the key points, we've got stationary points when we found that the change, when we found that the rate of change was 0, so the actual population must have had a stationary point, and the stationary point on this graph gave us a point of inflection on this one. Now we're most used to going from one of these graphs, analysing the gradient to look at one of those, but now you can easily check your work and say, let's just look at the gradient of this and see if it's reflected in what we have here. Positive gradient, yep, it's positive. 0, yes. Negative all the way along here, yes. Very negative there, yep. And 0 here, and then positive here. So positive gradient, positive part on the graph.